Assalamualaikum to Dr. Syarul Azmir. My name is Nurul Anis binti Muhammad Amin. My matrix numbers is CD240139. We are from group 6 and today we want to discuss and present about flow meter using sensor YF-S401 with prototype. And this is our group members. First, Muhammad Arif Nakiuddin bin Misnan, me Nurul Anis binti Muhammad Amin, Nur Ain Amalin binti Abdul Hadi, Muhammad Danish bin Idi Azhar, Nur Fatihah binti Sakian, and Muhammad Haikal bin Akril.
Baik, sebelum kita pergi lebih jauh, penting untuk kita faham dulu kenapa kita perlukan pengukuran aliran yang tepat. Dalam banyak sistem, contohnya macam pengurusan air, proses industri, sistem penyamaan udara dan juga pertanian, kita memang perlu tahu berapa banyak cahaya yang sedang bergerak dalam satu-satu masa. Kalau aliran terlalu perlahan atau terlalu laju, sistem itu mungkin tak akan berfungsi dengan baik. Dalam tanian, contohnya kalau air terlalu sikit, tanaman tak cukup air, tapi kalau terlalu banyak boleh jadi pembaziran atau kerosakan. Masalahnya sekarang, kebanyakan flow meter yang ada dekat pasaran memang agak mahal dan bukan itu sahaja. Alat tu juga perlukan kalibrasi atau penyelenggaraan yang kerap. Jadi untuk projek-projek kecil atau untuk belajar macam kita, benda ni kurang sesuai. Disebabkan itu, kumpulan kami buat satu prototype flow meter yang lebih murah dan praktikal. Kami guna sensor YF-S401 bersama mikro pengawal Arduino untuk mengukur aliran air secara automatik dan dalam masa sebenar. Jadi kita bukan sahaja dapat jimat kos, tapi juga dapat hasilkan alat yang berfungsi dengan baik dan projek-projek berskala kecil. Okey, seterusnya kita nak cerita sikit pasal apa maksud kadar aliran dan macam mana ia diukur. Kadar aliran ini secara ringkasnya ialah jumlah isi padu cahaya yang mengalir dalam satu pipe dalam masa tertentu. Kita biasanya ukur dalam unit liter per minit atau meter padu sesaat. Dan dalam sistem aliran ada dua jenis utama. Yang pertama iaitu aliran laminar. Ni bila air mengalir dengan lancar lapisan demi lapisan macam sungai tenang. Yang kedua ialah aliran turbulent. Bila air dah mula kacau bilau, berpusar macam arus deras. Untuk tentukan aliran ini, kita gunakan sesuatu yang dipanggil nombor Reynolds. Ia bergantung pada kelajuan air, saiz pipe dan sifat cahaya itu sendiri. Untuk mengukur kadar aliran, banyak kaedah boleh digunakan. Contohnya sensor mekanikal, sensor ultrasonik, elektromagnetik dan juga berdasarkan tekanan. Dalam kes kami gunakan sensor YF-S401 yang sangat sesuai untuk sistem air kecil. Cara dia berfungsi, bila air mengalir melalui sensor, dia akan berpusing rotor kat dalam itu, dan setiap pusingan akan hasilkan denyutan elektrik atau pulse. Okay, pulse ni akan dibaca oleh Arduino dan dari situ kita boleh kira kadar aliran.
Assalamualaikum, my name is Nurul Anis binti Muhammad Amin. My matrix numbers is CD240139. Today I want to share about design process. Next, I want to share about process video and system workflow. Firstly, the user fills water into the input container. And then 9-volt battery gives power to the Arduino Uno and the relay module. After that, the Arduino Uno sends a signal to turn on the relay. And then the relay activates the mini submersible water pump. And next, the pump push water through the silicone tube, and the water flows through the tube and enters the YF-S401 flow sensor. And then the sensor detects the water flow and sends pulse signals. And the Arduino reads these signals and calculates the flow rate and total water volume. And the result shown on the serial monitor. Next, I want to share about process video and system workflow. Firstly, the user fills water into the input container. And then 9-volt battery gives power to the Arduino Uno and the relay module. Next, I want to share prototype layout and components. First, battery, which is a battery used to power the whole system. Next, water pump and input container. which is used to store and push water into the system. Tubing and pipe directs water from the pump to the flow sensor, and the flow sensor detects and measures the water flow rate. And the water cup bridge holds the pipe to keep it stable and in position. And the relay module controls the pump on or off. And jumper wires connect the components to the Arduino, and the Arduino Uno controls the system and processes the sensor data, and the serial monitor displays the flow rate and the volume, and the output container collects the water after measurement, and the lastly modified cardboard frame, which is we used to support and organize all the components. Okay, this one last for our topic design process. And this is our circuit diagram. This circuit use a 9-volt battery to power the water pump. And then the Arduino Uno is the main controller. And then the flow sensor has 3 wires. First, red goes to pin digital 5 on Arduino, and then black goes to the ground, and then yellow goes to the pin digital 2. And then the relay module has 3 pins. First, VCC. VCC connects to the 5-volt on the Arduino, and then ground to ground, and then IN to the pin digital 3, and then the pump connects to the relay. The positive wire or the pump goes to the NO pin, and then the COM pin connects to the battery's positive and sends a signal to the relay, and then the relay turns on the pump, and then the water flows through the pump and the flow sensor, and the sensor sends data to the Arduino, and Arduino calculates the flow rate.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Ain Amali binti Abdul Hadi. My metric number is CD240271. So today I would like to talk about Arduino code in this project. So first, global variables, sensor pin, interrupt, setup, loop, and flow rate, and the total liquid calculation. And the last one is time control. So next I've moved to Arduino explanation. This Arduino code is designed to measure the flow rate and total volume of liquid passing through a flow sensor. It utilizes an interrupt-driven approach where the pass counter function increment the pass count each the time sensor detect a pass. So it is presenting a fixed volume of the liquid. In the loops functions, the flow rate is calculated by dividing the pass count by a calibration factor, and the total liquid pass in computed by multiply the flow rate by the absolute times. The result are displayed on the serial monitor in a real time. So it's allowing user to track both the flow rate in liters per minute and the total liquid volumes. So the use of interrupts ensure that pass counting is accurate and efficiency without depending on the main loops.
Assalamualaikum. My name is Nur Fatiha binti Sakian and my number matric is CD240168. The main goal of our experiment was to develop and test a flow meter prototype that accurately measures water flow rate. We aim to verify its ability to provide real-time flow rate and volume measurements and ensure its reliability under different flow conditions. We also aim to identify areas for improvement to enhance the meter accuracy. Next, for experimental setup description. Our setup consists of several key components, which is 1. Water tank holds 1300 milliliters of water for the experiment. Water pump, a mini submersible 3 volts to 5 volt DC pump. Flow sensor, which is YF-S401, to measure flow rate by generating pulse signals. Arduino microcontroller processes pulse and calculates flow rate and total volume. Relay module to control the water pump. Tubing and connectors to transfer water to and from the system. Lastly, output containers collects water after passing through the sensor. These components were assembled in a protective setup to ensure safety and reliability during the experiment. Next, for the procedure, we follow these steps. First, system setup. We connected all components and filled the tank with 1300 milliliters of water. Second, initialization. We uploaded the Arduino code to start monitoring the flow sensor data. Third, water flow. The Arduino activated the pump, sending water through the sensor. Fourth, data recording. The Arduino calculated the flow rate and volume, displaying result on the serial monitor. Fifth, repeat measurements. To ensure accuracy, we repeated the test 3 times. End of experiment. After collecting data, we powered off the system and cleaned the components. Data analysis, we compare the recorded measurements with non-standards to assess accuracy. Variables and controls. To ensure consistent result, first, independent variables. Water volume fixed at 1300 milliliters and flow rate controlled by the pump speed. Second, dependent variables. Measure flow rate liter per minute and total volume unit liter. Control variables. Water type purified, pipe length and diameter. Battery voltage, which is 9 volt, and sensor calibration set up to 4.5 pulse per liter per minute. By controlling these variables, we ensure the experiment accuracy and repeatability.
Assalamualaikum and good morning or good evening. My name is Muhammad Aifnakin Misnan and I shall be presenting the result and analysis from our case study. From the data gathering we find from the flow sensor, in the total of 957.64 milliliter, which is equal to 0.9576 liter of flow meter within the span of 2 minutes and 25 seconds. A table of data we created to find the mid-range of a flow meter rate throughout the time span, which is we taking the highest of limit from the data and also divide plus the minimum range of the data within the time span we taken for each in 30 seconds. So here we got the mid-range of the data given shall be the 287, 283.11, 281.33, 271.11, and 507.22. This is the unit in liter per minute. From getting the mid-range of the flow meter, we shall be converting the, the liter of minute to meter cube per second, which is 1 liter per minute is equal to times 1 meter cube over 1000 liter and darab 1 minute and 60 seconds. So that we can find the new data of a mid-range in meter cube per second. From then on, we'll find the area of the flow meter, which is from our finding of the spec of flow sensor will be 4 millimeter. So it will be pi times 0.004 in power of 2 over 4. So we get our area of the inlet of flow sensor will be 0.00001257 meter square. Within that, we shall be taking divided of the Q, which is our volume flow rate, divided by area. We shall be finding the velocity in meter per second. So that we shall finding our velocity within the time span in 30 seconds and 30 seconds, 1 minute, 1 minute and a half, 2 minutes, and 2 minutes and a half. So we find it the velocity along the time span in 30 seconds will be 381.5, 375.38, 373.02, 492.06, 672.53. As we can consider this is an anomaly here, we summarize that the finding of our anomaly within that the near ending of our operation here is that when the velocity of fluid is suddenly increases is because an air bubble entering the submersible pump. This is because when the pump supply the water to the flow meter, the vessel water inside the vessel will be decreasing and nearing the inlet of the pump. When the surface is suddenly near, the bubble from the surrounding entering the pump. This will be created a disruption in the supply tube, causing it the sensor will be disrupting and make the reading fluctuate. While our solution here will make the pump submerged we make the pump submerged deeper than the sample volume of the body of the liquid.
Hi, Assalamualaikum. My name is Michael bin Akrin. My number metric is CD240223. So today I want to talking about discussion on accuracy in the flow meter about about our project. So accuracy is a fundamental performance criterion when selecting and using a flow meter. It refer to how closely those how flow meters reading match the actual flow rate of a fluid. For example, liquid, gas or steam. The more accurate a flow meters is, the smaller difference between the measure and the true flow. So flow meter accuracy is usually expressed as a percentage of the actual reading. So full scale or calibrated spin, for instance, an accuracy of plus minus 1%. So just plus minus 1% of reading means, and the measurement can be 1% higher or lower than the true flow. So next is, I think in discussion for the flow meter is, we have factors affecting the accuracy for flow meter. So I think first is several factors can influence a flow meter accuracy. So several factors being installation, like installation port alignment and vibration or insufficient straight pipe runs can cause measurements errors. So second is, I think fluid characteristics changing temperature, pressure or viscosity and affect accuracies, especially for mechanical meters. So the last but not least, calibration without regular calibration, even highly accurate meter can drift and give incorrect readings. So next is improvement for flow meter. So what we have to do to improve our project or prototype for flow meter, first is about design improvement. So design is very important, right? So design can be modularity, create the prototype using I think it's modular parts, so that is maybe tested for various uses. So second is, I think about the functional enhancement. So user interest so I think its user interface include an LCD screen or mobile apps interface for real-time display of flow data. And the third is about accuracy and calibration. So accuracy and calibration is composition for environment a variable to adjust flow rate reading under different circumstances and add temperature and pressure sensor. So that very good for the flow meter to add the temperature and pressure. So the fourth is testing and validation. So testing and validation, benchmark testing assignment, the prototype performance in both lab and outdoor settings. So again, certified flow meters.